In this video, let's talk about graphs of systems of linear equations in two variables. So let's start with the first example, where it says, check if 0, 0 is a solution of the system below. So check if this 0, 0 is the solution of the system. X plus 3y equals 7 and x minus y equals negative 5. Well, on the first position of an ordered pair, it's always x, and on the second it's y. So here it's x and here it's y. So let's replace in the system everywhere we see x with 0 and everywhere we see y with 0. So we get 0 plus 3 times 0 equals 7. Well, this means 0 equals 7. That's false. So basically, the pair 0, 0 is not a solution of the system below. But I'm going to try to check the second equation as well, even though it does not matter. So 0 minus 0 equals negative 5. Well, 0 equals negative 5. That's false as well. So the conclusion is the pair 0, 0 is not a solution of the system. Now we can try and check if negative 2, 3 is a solution. So in the system it's x plus, it's still the same system. X plus 3y equals 7 and x minus y equals negative 5. So negative 2 plus 3 times 3 equals 7. Well, negative 2 plus 9, it does equal 7. So it satisfies negative 2, 3 satisfies the first equation. Now we have to check the second one. So negative 2 minus 3 equals negative 5? Yes, it does. So because negative 2, 3, the pair negative 2, 3 was satisfied both equations, then we call this a solution of the system. If works out only for one equation, it's not enough. It has to satisfy both equations. So let's continue by solving a system of equations by graphing. So we can see in this example 1 that we have two equations in two variables. So this is equation 1 and this is equation 2. And we want to find their solution. So we want to find, like in the previous example, the pair that when you replace x and y in both equations, the equations are satisfied. So, or you get a true statement. So to do that, let's start with the first equation, which is x plus y equals 4. And let's write it in slope-intercept form. That means y equals negative x plus 4, which means I can write negative 1 over 1 x plus 4, so I can identify that the slope is negative 1 over 1, and the y-intercept is 4, so that's going to be easier for us to graph it. Let's do the same with equation 2. So 2x minus 3y equals 3. I'm going to write negative 3y equals negative 2x plus 3 because I want to get y by itself. Divide by negative 3 and we get y equals 2 over 3x minus 1. So in this case the slope is 2 over 3 and the y-intercept is negative 1. So let's draw each of these equations in a coordinate plane. So we have the coordinate plane, the x-axis, the y-axis. And I want to graph the first equation. Let's not forget this is the first equation and this is the second one. So in order to graph the first equation, we start at 4, which is the y-intercept. So 1, 2, 3, 4, and we bubble that. Then, because the slope is negative 1 over 1, we go down 1 unit and over to the right 1 unit. So this is the second point. So now let's graph a line through these 2 points. So this is my first line. let's say this is. All right, now let's solve the second. Let's draw the second line. So -1 is the y-intercept, so we start at -1. And then we go up 2, so 1, 2, and over 3. So that would mean this point. So this point that I forgot to bubble, write the -1, and then that point. So now when we draw the line through these 2 points, we notice that they intersect. And they intersect at this point, right? That's their intersection. So this point here of coordinates x, y, which we'll have to figure out, is the solution. So it seems like this point it's 3 and the y value it's 1, so it seems like the pair 3, 1, it's a solution. So just to be 100% sure, I'm gonna check if that's correct. So I'm gonna check if 3, 1, it's a solution of the first equation. So let's see, 3 plus 1 equals 4. Yes, it does. And then I'm gonna check the second one. 2 times 3 minus 3 times 1 is equal to 3. Well, 6 minus 3 equals 3, so it does check. So basically, the point 3, 1 is a solution. Now, the problem, so the graphing method, it's good to visualize what it means to find the solution of a system by graphing. But the downside of solving the system by graphing is that it's not that precise. You see, like even this point there, I was wondering, is it 3 or maybe you have to be very precise and accurate in your drawing to make sure you get the correct answer. Let alone, sometimes there are systems that of equations that have these 2 solutions. Well, that's going to be also hard to figure out on the graph. So while the graphing method, I want you to look at the graphing method as a method to visualize what happens with the solution. So to have a solution of a system means that the 2 lines that we were graphing should intersect at one point, and you have to figure out the coordinates of that point. Now let's take a look at this example. So I still have a system of 2 equations, 2 linear equations with 2 variables, and I want to solve it still by graphing. So this is first equation, 3x minus 2y equals 6, and 6x minus 4y equals 18 is the second equation. So let's start with the first equation, 3x minus 2y equals 6, and I want to write it in slope-intercept form. So negative 2y equals negative 3x plus 6, divide by negative 2, and we get y equals 3 over 2x minus 3. And this is the first equation that I'm going to use this slope-intercept to graph it. Of course, you can use giving points if you want to graph it as well. Now let's, or intercepts, it doesn't have to be slope-intercept form, but I like the slope-intercept form. So we subtract 6x from this one, negative 4y equals negative 6x plus 18. We divide by negative 4 each, and we get y equals 3 over 2x, and then minus 2.5. So let's graph it. The coordinate system, x-axis, the origin, x-axis, y-axis, and let's graph the first equation and then the second. So the first equation, we start at negative 3, 1, 2, 3, negative 3, that's the y-intercept, we bubble that. And then we go up 3, because of this, up 3. So 1, 2, 3. And then we go over to the right, 2. So then 1, 2. This would be the second point. So then let's graph the line through these 2 points. Oops. Well, it went straight for a little bit. All right, and then I'm going to graph the second one. So, negative 2.5, so that would be around here, negative 2.5. And then we go up 3, so that would be 1, 2, 3. So we go to 0.5. And then to the right, 2. So I have to bubble this. And then to the right 2, so that would mean this one. So now when we connect the red dots, what do we notice? Not too skilled with the lines. Well, we notice that the black line and the red line are parallel. And that's also given by the slopes. The slope of this line equals the slope of this line. So basically, line 1 is parallel to line 2, which means the system has no solution. So graphically, if the lines are parallel, they don't intersect, then there is no solution. There are no there is no x and y that replaced in both equations gives us something true. And finally, let's look at one more example. Y equals 2x minus 2 and 15x minus 5y equals 10. I want to solve this again by graphing. So the first one, if we take a look, it's already in slope-intercept form. And the second one, let's work on that. So equation 1 and equation 2, so plus 15x. Oh, sorry, I want to move it. So equals negative 15x plus 10. So we move the 15x on the other side. We divide by negative 5 every single term. And we get y equals 3x minus 2. So that would be the second line that we want to graph. So let's draw the coordinate plane. The x-axis, the y-axis, right? The origin, x-axis, y-axis. And let's draw the first line first. So first line, y equals 2x minus 2. So we start at negative 2. And then we go, so 2x means 2 over 1. We go up 2. So negative 2 is a point. And then we go up 2 and then over 1. So that means the second point. And now we draw a line through these 2 points. Why it looks like I have 2 lines here. All right. There you go. The best I can do. Now let's do the same with line 2. I'm going to draw it red. Again, it starts at negative 2. But it's 3 over 1 this time. So it goes up 3. 1, 2, 3. And then it goes over 1. Okay. So when I connect them, when I draw the red line, we notice that the 2 lines, the red line and the black line intersect here at this point. Well, maybe it's not that clear. Again, it's being very attentive to how you get the numbers. And that point is of coordinate 0, negative 2, which is the solution of the system. If we have doubts, we can always replace. So in the first one, negative 2 equals 2 times 0 minus 2. Yes, it does. And in the second one, 15 times 0, that's 0, minus 5 times negative 2, does that equal 10? Well, negative 5 times negative 2 is 10, so it does equal. And let's do really quick one more example. If we have these two equations, y equals x plus 2 and 2y equals 2x plus 4. So this one is already in slope-intercept form. How about the second one? Well, I would just have to divide by 2 every single term and we get x plus 2. So when we graph them, if we graph the first line, and you probably already noticed where I'm going, so 0x and 0y. If we graph the first line, we go to 1, 2, bubble that, and then it's 1 over 1 in front of x, right? So we go up 1 and over 1. So when we draw the line, we get this line. So this is the first line. And then the second one, where we graph it, well, again we go at 2, and then again we go up and over 1, because you probably notice it's pretty much the same equation. So when I draw the line through it, well, we can notice that the red line and the black line overlap. So basically, we have infinitely many solutions. So basically, this point, it's a solution because it's on both lines. This point, right, they intersect at more than one point. This point, so they have infinitely many solutions. So how do we write that? Well, we usually write it like this. The set of x and y with the property that y equals x plus 2, right? We just pick one of the two equations and we write it like that. Why? Because, for example, if x equals 0, y equals 2. So basically the point 0, 2, which 0, 2 is this one, right? It's a solution of the system. But I can also pick 0, x equals 1. So that means that y equals 3. So the pair 1, 3, it's also a solution, like the 1, 3. This is the point. That's a solution as well. If I choose x equals negative 1, y equals 1. So basically the pair negative 1, 1, it's a solution. So negative 1, 1, it's also on both graphs. So in conclusion, a system of two equations with two variables can have one solution, x, y, and the system is called consistent, lines intersect. It can have no solution, the system is inconsistent and lines are parallel. Infinitely many solutions, the system is dependent and the lines are overlapping. I hope this helps.